Hi guys, how are you doing? This is the Ethereum developer course for the Morphosis Swarm on One High community, and today is the lecture number 2. We are gonna be doing a first. We are gonna review a few points and advanced topics that we barely touch in the first lecture, using again its build to showcase some of the specific sections and parts that are involved. Then we are gonna jump into using a new tool, Scaffold-eth, that is gonna be our main tool for the next lectures, and it's gonna help us to set up a proper development environment. We are gonna do spending some time there, doing a few examples and doing a general overview of the environment. And finally, we are gonna showcase a few Solidity examples in there with a different contracts and learning a few of the basic concepts in Solidity. And then we are gonna show some small things and talking about a few things involved in the setting up an environment. So yeah, to start, we are gonna be focusing a bit into the ABI and what it is and how is and looking a bit more into the details of what we did previously. If you remember, in the last lecture, we have a contract. In this case, I'm using the checking contract for the for the checking contract for the task that we did in the first lecture. And what we did in the first lecture was compiling this contract using the compile module and getting two things to the outputs: the bytecode, that is the machine code that the EVM execute, and also the ABI. And the ABI is what we are going to be spending a bit of time trying to define and better um, explain a few things related to it. And to recap, the ABI is a standard that was implemented to um, help both the low level EVM contract to contract interaction to understand when two contracts are sending message between each other, but also as a way for externally owned accounts, so addresses like we usually use for users, to also send messages like we did in the first lecture about sending a transaction to a contract. And the ABI is defining all the interactions that are possible and how those interactions should be done properly. So we are going to be now doing a few examples and trying to show what is happening under the hood in the ABI. So if you remember, what I'm gonna first take the check-in contract that we had in the first lecture. So we have it. Let me check if this is the one. I think. Um, okay, I'm gonna take this is check-in. Let me check the code. This is a more advanced that I'm gonna use later. So let me look for the other one. Uh, yeah, let me. I think it's in the should be in the Discord server for the course. I thought I had it here. Sorry that. Let me check. EVM. It should be in the task here. Yeah, this is the address we are looking for. So let's bring it. Okay, now we can see that there is a lot of transactions that you send to interact with the check-in contract. And here is the whole information about the smart contract. And let's get the ABI. That's what we want to input here in the object. Now, once we did, we are able to see the whole methods and that we can interact with. And also let's put the address that we are of the contract. So we can have it here. We can double check is the right one using the block key. And yeah, now that we have this address, let's put it here. We can go ahead and interact with the check-in and see what is generated. So as you remember, you can probably have to do something similar when you were doing one of the tasks in the lecture one, but you maybe don't fully understand what this block of text or this bytecode that is calling this string of text is meant. And what it is how the ABI is encoded. So the EBI, to be understood by the low-level EVM, should be encoded in a specific format that is defined by the ABI specification. And I'm going to link the whole specification so you can check more in detail all what that we will be talking now. But this encoding is having two sections primarily. First, the what is called the function signature that we are calling, and then the encoding of the whole arguments that we are sending with the method. So first we have the encoding of the function that we are calling, and then the encoding of all the parameters that we are sending. So let me look for the kk hash. We have this. So to explain a bit, and I was looking this tooling that is allow me to create a hash of a string, and using this kk 256 kk hash, and this is the hash that Solidity used in their code to create the signature, the hash of the signature of the function. So in this case, the encoding of the function we are interacting, in this case check-in, is actually encoding using the kk hash, and we can check it in this way. Let's get the check-in function. Let's go to the tooling, and this is generating this hash, no? Once we, but also the ABI specification says that we only need to provide the parameter types between parentheses. So if in this case we have the check-in, and it's gonna be only a string between parameters. No? So now that from this string of text, once we apply the hash of this kind, the kk hash, we are getting this whole hash byte. And if we check, the first 8 characters or 4 bytes are the one that we, the specification of the ABI, use when it's generating this block of text. So yeah, sorry, here, if we check this text, the first, and let me go with the size a bit bigger. If we check, we have F21BB4C5, and it's the same as this one. So the ABI specification is saying that if you want to interact with the check-in function of this contract, you should encode the signature using the first 4 bytes or first 8 characters of the kk hash of this of the signature expressed in this way. So that's the first part of this data, and then we have the encoding of the parameters that we are using. In this case, the only parameter is the name. So this is the default, that is going to be the empty string that is all zeros. But if, for example, we use Gabi, this encoding is going to change, because this now is the encoding of this of the string representation of the byte representation of the string Gabi. And this string may be a bit difficult to actually see more clearly because the encoding of the byte representation of the string Gabi is a bit more difficult to express, or not to express, but to easily see what it is. But if we do some hex to UTC converter, we can see or bytes to UTC or UTC converter. Let's check UFT. Let's check converter. Yeah, this tool is really useful. The online UTF-8 tool, and help us to convert between hex and text. So let's, for example, if we put this, we're gonna get the UTF-8 line of text. So this is the hexadecimal representation of Gabi. So this was more difficult to actually see it. But then to make an example a bit more clear, let's create a new check-in function. In this case, let's gonna use remix like we did previously. Let's put check-in true, and instead let's give an address of the student and uint 256 of ID. And let's also create a new mapping with students that is going from address to uint 256, and let's store this inside the students, put the student address and use the ID. So we add a simple function that is storing in this students mapping these new values that we are passing. Sorry. So now the compilation worked correctly. We are connected to Rinkeby, and we are gonna deploy this contract to the blockchain. Let's see if it's connecting once again. Okay, now we are gonna send this transaction to the blockchain, and once it's mined, we are gonna be able to see the check-in here. Let's get the address and let's get the ABI and put it in the new ABI here. Let's use the ABI here. We get the new check-in, the new public functions, because now I made these two publics as well to see the names and the students, and let's also get the address that was deployed to update here. Oh, sorry. And now, yeah, instead of using the check-in, let's get the check-in too, and let's give an address. In this case, let's use the default MetaMask address that I'm using here, and let's put the number 3, for example. So now, once we get the student and the ID, and we are getting this new text, this new data. And if we check, we get first the signature, but the signature now is a new one. So let's get this signature to check if it's the right one. Let's go to the Keka hash here and get the new format. So only the address and only the uint 266. This is the only how the API requests us to have this format. So if we check the hash of this Keka 256 with the value we are getting here is AD H245B8 AD H2, so it's the right one. So we are interacting with the right check-into function. That's what we want. And then we are also encoding two of the parameters, the student address and the ID. And if we check, in this case, it's more easy to see the right information. We are getting the address that we want to interact here, and we are also getting the number 3 here. And all the other extra information, like in this case, we are getting a lot of zeros added on the top, on the front, as well as in the second case, is how the API requests the encoding to be made. So in this case, we are always requesting to be a byte 32, if I'm not mistaken, and have it in that format. So as the address is small in size, in character size, we get all these upfront zeros added to the so the encoding is correctly done. And now that we have this, let's create a transaction using this information. So I think we have here a transaction already connected. So let's sign the transaction with this. We need to put this data probably. Yeah. So this data should be in the call data, if you remember, because what we are actually creating with this is the data that we are going to be sending to the transaction, because we are telling the blockchain with which contract and with which method and with which parameters we are sending to the contract. And we are also connecting the address. If you see the 2 of the transaction is connected to the address we have defined here, the one that we just create. And the data that we are generating is the one we want to send to with the transaction message. So once we sign this message, we have all that we need. We have the data here with that is telling, okay, we have the 2, that is the address of the contract we are sending, and we have the data that is describing which kind of information and we want to send to the blockchain. And in this case is, okay, we want to interact with the check-in to method of this contract, and we are sending an address and a number as parameters. So yeah, once we do that, we can sign this function, and we get the transaction hash here. And let's see, probably the transaction hash is here. It's still processing. Give it a few seconds. And yeah, that was already processed. And if we check here in Etherscan, it's telling us more context about, okay, you are interacting with the check-in to function, because Etherscan is detecting and this contract is verified, so Etherscan can give you more context about what is happening. And then we are getting the parameters a bit more easy to see here. But if you actually see the original message that the input data we sent is the one we just saw. And if we decode this data, we can see the 2 parameters that we are sending. We are sending the student with the address here and the ID with the address with the number 3. So yeah, this is what is happening under the hood when we are interacting with and sending a message, and how the ABI is how the ABI is describing how we should encode this information. So yeah. Now to continue with our next point that we want to address is something that related to also to the ABI and to how information is sent to the blockchain, and is what is called events in Ethereum. And for doing that, let's update a bit this contract, and let's create an event. And an event, if we is defined with this syntax, we have the event, and we should give a name. So we can say set student, and we should provide what we want to emit in the event. So in this case, it's going to be an address of the student. So yeah, and then once we have this defined, we can use it in our contract. So in our case, we are going to use it in the new function checking2, and we are going to use it with this syntax emit and the name of the event we are going to call, and we are going to give the student address in this case. So now we have this new contract with an event included. So let's deploy this new contract to the blockchain. Okay. Okay, we get it. We get the function. Yeah, sorry, the address, and we now are gonna let's verify the contract as well. Yeah, probably it's not mined the transaction yet. So let's try now. Okay, let's wait a bit. Okay, let's do it a bit later. But now we are gonna take the new ABI. So let's copy this ABI and let's put it here. And let's use the new address as well. So we're gonna get the address from here, second one. And let's try to verify now the contract, like we did in the lecture one. And the contract was verified, so we are gonna need that then to look a bit more in details. But now what we are gonna do is using the same information that we previously did. So actually in this is not changing at all, so we are getting the same. But now once we send this new, let's sign the transaction and let's send it to the blockchain. But what is gonna be interesting is the new receipt that we are gonna get. And previously, let's wait a few seconds, and okay, we get it. And maybe I didn't show explicitly, but previously in this receipt object, this log was empty and there was no information here. But now as we are having an event, we are getting this. And one thing that is important to notice that I didn't mention it is that the events are like what allow us to be more give more context to the information we are sending into the blockchain. So for example, here we are let me recap that. So the events allow us to give more context of what is happening in the specific contract, because sometimes we don't want to store every information we are dealing with in the contract itself and the state of the blockchain itself, because it's really expensive. and it's gonna cost a lot for users or for us to do things with the contract we are using. So in those cases, what we usually do for that is emit these events as a way to store data, but not on the blockchain itself, but have a way to keep track of that information off chain. So there are several libraries and toolings that allow us to use those events and read those events from the logs and from the nodes that are processing our contracts without getting extra expensive to keep track of them in the blockchain itself. So in this case, what we are getting is these logs as we just send the transaction. And the difference with the previous example is that now we get extra information in the log, and this log is only kept in the off-chain, in the nodes of every computer that is processing our transactions. And this is helpful because we didn't emitting this event in the contract is really cost efficient, and regardless, we get more information about what is happening in our contract. So to go a bit more in the details of what this log does and how it works, we get this array of information, a new log per event emitted in our transaction, and in this case we get only one because we only have one event. And now the data that we have is mostly a lot of context data about the address of the contract, the block hash, a few other things. But the two important things that I would like to show is this one, the data, and the topics. These are the two that are most useful for us when we are dealing with events and logs. And first, the topics are describing a few things, and the first topic is always the signature of the method that is being emitted. Sorry. So in this case, if we check this topic is with the signature of the event, let's go and get the event. In this case, student, and let's take it in the Keka. In this case, with the same ABI format that we previously used for functions, and we check that this is the hash, and is starting with D9343 and finalizing with 6178. And if we check, is that one exactly that one? And this is so the first topic is always describing the event signature that is being emitted, and then the data is where is storing the actual data that is emitted. So in our case, if we check, we are emitting the student address, and this is exactly the address that we just sent with the encoding that the ABI used, as we previously saw. So if we check F3 and finalizing with 2266 is the one that we have here, 932266. So that's the data, and yeah, that's the general overview of events. But there are some caveats that we need to review, and that's some specific use case that exists with event. So if we have, for example, here a index set, we have this extra syntax called indexed that allow us to be more precise in the way that these events are handled in the log, because the log is a structure that lives in the Ethereum nodes and is not super efficient to be processed, because all the logs are stored per block, and find the exact event sometimes gets difficult if there are, because there are a lot of events put together from all the transactions that happen in a block. So what we usually do to improve the filtering and found those events more easily is put a indexer here that what it does is make it more easy to find that particular information. So let's see what happens once we do that. So let's deploy again these new contracts with the indexer. And once we get let's get the ABI first. Oh, sorry. And let's get the address. Okay, now we have the same data. This is not gonna change, but once we sign the transaction and send it, let's see how that changed the behavior. Okay, so now we get the new receipt, and if we check now the log in the data, we get nothing, but instead in the topic we get two values, one for the same signature that identify the event, and then the data of the address that we are sending is actually in a topic as well. So in this way, it's more easily to find with the topic that information, as it's more handled in a more efficient way once with libraries that we are gonna be using later. So finally, let's put it a bit. Let's add also a new uint 266 ID. Let's also add this new value to make it a bit more interesting. Let's deploy this new contract. And yeah, let's get the ABI once again. And let's do the process once more. And the new address. So we have the new address. Let's put the same values. And finally, let's send the new transaction. And after a few seconds, we're gonna see what's happening. And in this case now, we are getting the log again, but now we have in the data we have one value, and in the topic other value. So we are getting the indexed value, we are getting it in the topic, and the data only has the ID. So there are one case more probably that I'm gonna just write it here. If we get it all without indexing, we are gonna get instead the data in this way with the usual encoding of ABI, and this is gonna be empty. So, sorry, only having the signature. And instead, if we get this other way, we are gonna get, if the two of them are indexed like this, then we are gonna get this new where data is gonna be empty, and we are getting the two values in the topic. So those are the whole spectrum of things that can happen with events. And to give you a bit of let's create, to give you a bit of more of context of how this is useful, let's get this events module, and let's put the name of the event here. So set student, and once we call this, we are getting here an object that has all the information about the events that are happening. So what this is doing is processing all the values and processing all the information in the blockchain and only getting the events that are important for us. In this case, the events related to the set student for this contract. So if we, for example, send a new transaction here, then once the transaction is mined, we are gonna see that this object has a new element with a new event. And this is a simple version of what is gonna be happening in a more high level library, where we are gonna be seeing more how this kind of logic is used in a more complex way to process the whole event. So this is not sending anything. Oh yeah, maybe I need to sign, send. Oh yeah, I forgot to sign to update the nonce probably. Now that we have the new element, let's see if this is updated as well. Yeah, we get the new event now. That in this case is actually the same event, but yeah, we have two of them because two of them happen in the last transaction. And what is great about this is that we eventually will be able to filter by specific rules, or even say, okay, we want only events through a specific range of blocks or in a specific block. So this kind of tooling is going to be useful for get the specific information we want from events. Okay, this is everything that I want to share on these two topics. Now I would like to give a quick overview of Etherscan. That is something that we've been using now for some time, and we didn't let's use the new address to make sure this is verified. I think this one was the one we verified. Yeah, no, we didn't verify it. Let's verify it. Okay. Oh, sorry, no there. Now, once it's verified, I'm gonna show a few things. So Etherscan is like the blockchain explorer, and it's like a way to see what is happening in the blockchain in an easy way, because everything is public. So we can see, for example, each block, what are the transactions that each block has, look into whatever transaction we want and see what happened. And for example, we can search by transaction hash. The final thing that I wanted to show you from Etherscan is how other things we can see in Etherscan, and what kind of things allow us to go into a bit of more of details. So this is a contract we implement with the events, and we have here a few transactions we did. So if we go to the transaction, we can see, like we did previously, all the data we sent, like we previously did. And then we have this other tab with a log, with the logs that are happening in this transaction. So in this case, like we previously saw, we only have one log, and we have all the information that is important. In this case, the name of the event that is processed, the topic hash number 0, that is the hash of this signature, the first parameter, the parameter 4, that is some of the information we send, and yeah, that's what we wanted, the information, how Etherscan is processing this information. And then The other thing that I wanted to show is that we can also read information from Etherscan. We can get students given an address and get that, or get a student ID given an address and everything that we want to do when we are interacting with a contract. And then we can also write into the contract, so we can actually send a transaction from Etherscan, and we need to connect to MetaMask in this case. And once we are connected, let's check. Okay, we can, for example, check in name or send the transaction. So this is other way of that we can also interact with the blockchain. In this case, using Etherscan. So now let's go ahead and start jumping into our development environment that we are going to be using from now on in the next lectures. And this is Scaffold-eth. And Scaffold-eth is a really interesting repository that was also made by Austin Griffin that allow us to really quickly prototype and iterate on our smart contracts and really have everything we need actually. And you can I encourage you to later also review the whole repo more in details and all the great documentation that it has. And once again, I want to encourage that don't feel bad if you don't understand several of the things we are gonna be seeing, but no worries, because in the next few lectures we are gonna keep adding more context on the different parts of this repository. But now we are only gonna be focusing on really specific things that we are gonna be seeing next. And one other thing that I spend some time doing is to make your life easier through the lecture is preparing this whole quick start that is have some requirements, and you need to set up everything on your local computer to make it happen. I create this Gitpod that is a technology that allow us to have everything done on the browser directly, so we can develop in an environment without having to have all the requirements needed and do everything in the browser. So I think you are going to be liking this to jump into the action without needing to have a lot of proficiency and setups right beforehand. So the only thing you need to do is set up an account with Gitpod. You can probably do it with email or GitHub account, and then it's gonna be starting several things that I'm gonna describe in now while it's loading. And yeah, I'm gonna be walking you a bit into the structure of this environment. But once again, let me encourage again that probably there are a lot of things that you are not gonna understand right away, but no worries. Let's focus in this lecture only on the specific things that I'm gonna show you, and leave the other things for later. And once you start getting more context of everything we are doing. So now this is initializing my space. It's taking sometimes, but once you do it once, it's gonna be working every time the same way. And now let me see, because I think I did one thing that I like, because one configuration that Gitpod allow you is, if you go here into the settings, allow you to have this feature preview that allow you to use code instead of the default that is Thea. This Thea is like a IDE that give you that they create to use in the browser instead of Visual Code. But like I like more Visual Code, so I use that. But let me anyway create one with Thea as well, so you can as well follow with me in the same way that you're gonna see it once you start, because this one is gonna be using VS Code, and I don't want you to confuse you with other things. So yeah, let's close this one and wait a bit for the other one that is doing the same again, but with a new IDE, the new tooling. So you don't need to worry about this configuration that I just did. This was only something that I did to improve my my personal configuration. But once you only need to click into the Gitpod and it's gonna be working right away once you get an account. And this is the actual setup that you are gonna be seeing. And what you are gonna be seeing right away is you have these three terminals here. One is having the first of all, this is installing all the dependencies and all the things that you need to run this package and the whole exercise and the whole repository. Once it's installed, here is gonna be running the application server. Here is gonna be running the local blockchain using Hardhat, and here is gonna be the how you are gonna be interacting with the with the with the repo and deploying in the first command that is gonna be sent is a deploying that is gonna deploy the example contract that this repo has. So from in this side we have this structure where all the different files are, and from here you don't need to worry about anything for now. You only need to go to inside the packages that we have three packages, one for subgraph that we are going to use later, one for our React application that we are going to use later, and here the one for for Hardhat. And we only need to worry about the one for Hardhat. And inside Hardhat, even inside here, there are a lot of things happening that we are not gonna cover now. But you only need to worry about this folder contracts and this file. So we are only gonna be focusing on this file, the contract file, and you are gonna be seeing that this is not color coding, and I think it's because not sure why it's not loading this Solidity theme that is gonna color code our code, but it's not working now. So probably when you are gonna use it, it's gonna work for you right away. So you are gonna, instead of seeing something like this, you're gonna see something like this. But yeah, I'm not sure why it's not loading now. But to continue, this is the only file you need to worry for now. This your contract that's all, and everything is gonna be handled for you. So in here, now that this is already loading. So now you are probably having this preview here. If we update it, we are gonna see the application, and we can click here to open in a new tab in the browser. So let's do that. And this is already connecting with the blockchain. If you check, it's doing requests. And the other terminal here is what it did was deploying the contract using a script. That is, don't need to worry how that's happening for now, but this is doing some stuff, and then it's just deploying the contract, like sending a transaction like we did in previous examples, sending the transaction and creating a contract in this address, and then the address is used in the front end to showcase. And now I'm gonna show you the front end. This is a simple application front end that is doing a few things for us. And to start with it, let me explain a bit what are a provider. And providers are something that we've been using also for some time. These are described as well in the documentation here a bit. So I encourage you to check out the whole README that had a lot of interesting things described. So if we go here in some place, there are here the providers description, and like it says here, providers are connections to different blockchains. So providers are a way to actually connect to a blockchain. And for example, in the repo that we are using, we have three kinds of provider. We have a mainnet provider that we are not going to use for now, that connect to the main Ethereum blockchain. We have a local provider that is the one we are using that is connected to Hard Hat network, in this case, like here. And then there are injected providers that are the ones that, for example, MetaMask or Wallet Connect. And so then this also using the burner provider, that is a special provider created also by Austin Griffin that you can then check the documentation. But what it does is generating a new provider every time from and allow us to be more quickly check things. So for example, here right away we have the burner provider using here that is generating a new address right away. Every time we are running the front end, we have a new address here. So we can directly start using if we didn't get found here because it's generated on the fly, but we can use the faucet to give it some founds. So we are gonna do that. Now we have a few founds here. And then we are gonna be also connecting to, we can also choose to connect to MetaMask if you want. We're gonna do it later, probably that. And now we have founds, we can start interacting with the contract. And here in the front end, we have the contract with a user interface that allow us to interact with it. And we can see, and let's see the contracts a bit in detail. So we have, we have this contract that is a simple contract that have an event that is set purpose, that, and then we have a purpose value that is build unstoppable applications, and only a function that what it does is that once we provide a string of new purpose and is storing that value and then emitting the event with the address of the that is setting the purpose and the new purpose. So now we can interact with it. We can see that the actual value of purpose is the one displayed here. And if we now put a new purpose, we can see that we will be sending a transaction, and once it's mined, we see that the new purpose is updated. And like we are using a local blockchain, everything is really quick, so we get the feedback right away, and that's really interesting to check things and test. So we are gonna be doing a few things now. So yeah, then the other things here are a few like events. There are a few things showing up here, but you no need to worry about this for now. And now this is was the general overview of what everything that we have available in this environment. And now we are gonna be doing a few Solidity examples to check and test a few things and learn with practice on Solidity. And for doing that, we are going to be using the Solidity by example repository. And this is a really cool way of using Solidity because allow us to check our assumptions really quick and learn a specific topic doing with a specific example. And the way of doing it using this Scaffold-eth UI is really quick and easy. So let's start with this first application. That this is a simple counter, and we are gonna take this logic, and we can put it here to see that more clear, because in the other it's not gonna show so good like here. So we only have a variable, public variable count, and we have three functions. One that is just returning the value of the current count, one that is incrementing the count, and one that is decrementing the count. So we can go ahead and update it in the code here. Let's do it. Update the code of our contract. Let's put it there. Now we need to do in this terminal, we need to do two things. First, like we did before, we need to compile, and this is gonna be updating the whole artifacts and ABI and everything that is used by the front end, and then we need to also deploy. And once we deploy, the new transaction is sent in the blockchain, and we can see it here. This is a transaction that we are sending. The new address of the contract get displayed here, and also automatically the front end is updated. So now if we go to the front end, we are gonna see that we have a new contract displayed with the several things showing up. We have the value that is public already displayed. We get the get function already displayed, and now we can also this is okay. Yeah, we can also decrement and increment with a transaction. So let's do that. Let's increment by 1. We are sending a transaction, and these values are updated. Let's do it once again, and let's decrement once. And that's really cool because we can directly interact and check what our contract is doing. So yeah, let's go ahead and check another contract. Let's do these primitive data types. These are a showcase of the different types that are allowed in Solidity. So let's put it here to see it more clearly first. And one thing that we need to update here is to make every variable public, because we want to show it in the UI. Otherwise, it's gonna be only internal, so we are not gonna be seeing anything. So let's update these few values here, and now let's copy once again, but for the for our environment in the browser. So let's do it once again. Let's copy this here, and this is yep. And now let's do it once again, the same commands: compile and deploy. Oh, sorry, yeah, and deploy. Now the same again. The transaction is sent, the front end is updated, and now we get the new UI. And if we check, we have all the values already displayed that we were seeing. We get an address, we get the default, the value of true, we get the default address that is the 0x0000, the default boolean that is false. And one thing that is interesting about Solidity is that that's why default all the values that are no, in Solidity does not exist the concept of null or empty. You always, that every time that you define a variable, it is defined by the default value. And for example, for booleans, that's false. For uints, that's 0. For address is the address 0, so 0x0000. And we also have a more complex structure that we're gonna see next, that also has is initialized with 0. So yeah, let's go ahead and see the next example. For example, the mappings that are a really cool structure in Solidity. And mappings are like a way to store data with a key and a value. So for every key, we have a value. And yeah, let's copy this one. First, we can copy here, like we previously did. So if we check, we have a mapping that is this structure. In this case, is storing for every address a uint. And as we just said, in in Solidity, every value is initialized with the default. So in here, in mappings, in this case, for every address, we will have the uint0 as default. And then once we start changing those, are going to be updated. So let's go ahead, and the other functions are to get the data, to set the data, and to remove the data from the mapping. So yeah, let's update this one here. And let's compile once again. And let's deploy. Okay, now that we get the new front end, it's gonna update it, and we have these few ways to interact. So we will get the address, but let's set, given to this address, let's set it the 3 value, and if we get it here, we're gonna get the value 3, and then if we remove it, we are gonna see the default value that is gonna be the 0. So we can keep playing around with all this, and I encourage you to do that and test your assumptions in practice. Let's go ahead and check also the structs that are a more complex data type that allow you to create more complex structures. So for example, in here, let's copy this code. So we have it here. So we have a struct, and these structs are the way that are defined with this syntax. So we will have like an object of different values. In this case, we have a string of text that is called to do. The struct is called to do, and we have a string of text and a bool that is telling us if the to do is complete or not. And then we are using that as that struct as an array of to do. So we have a to do's array. So then we have a few methods: one to create a new to do given a text, one to get an existing to do from the list, one to update, and one to mark it as complete. And to go quickly through this one, we can also update it here. Let's yarn compile and yarn deploy. And now we have a few methods here to interact. And for example, I can create watch videos of Morphosis. And now we can get the first list, the first element on the list, and see that watch video of Morphosis is false because it's not done to do yet. But once we toggle the first element as complete, we can check that that one is gonna be true. So we already watch it, and we will toggle as complete our one of our to do. And yeah, let's continue with another example that is interesting. That is the modifiers. And let's watch where it is. Yeah, function modifier. So this is an interesting one, and modifiers are like a way of allowing to run code before or after a function call. So let's copy this one to here to first check it out a bit. And to give a bit of context, yeah, this is gonna be used to showcase these examples. We are going to use a few variables. We have a constructor that the constructor code is executed once we deploy the contract. In this case, we are setting the owner of the contract as the message sender. The message sender is a global variable that we can access with the values that are in the message. And then we have our first modifier that is called only owner. And what it does is using this other syntax called require. And require is a way of putting like a condition. And if that condition is not met, the transaction is reversed, so it's cancelled. So in this case, we are saying that if the sender of the transaction is not the owner, we are not allowing this to happen. So this modifier can be used then in a function, like in this case, change owner, only owner is used here. And how it works is having this syntax with a hyphen, and what it does is it's gonna be doing everything that is in the change owner function after this line of code. So in this is the same as if we were doing this, and this modifier, this is the same as putting this modifier here and removing this line of code, because everything that is here is gonna be what is described in the function. So in this case, what is be happening is only be allowing to change the owner if we were the previous owner. So this is really important for security reasons, that only us allow to change important administrative method, for example. And we are also putting another modifier here that is only allowing the address of the new owner to be different from the default address, the address 0. And then here we have another example of a modifier that does not allow to re-enter the same functions more than once. So if we are decrementing this with a value more than once, then the second time is gonna revert. And let's go ahead now and use this in our environment. Okay, we're gonna update here, and we are gonna compile and deploy. Once we get the updated value, we are gonna see that we have a few ways to interact. And first of all, as the actual, we can see that the owner is this address, and we can see this address is the actual, this the first address that is the default address of the hard hat blockchain, local blockchain, and that's why this is the address. And I have the MetaMask configured to use, but yeah, let me continue with the example. If I try to change the owner to this address, the burner wallet address that we have here, I'm gonna having a transaction error with a exception of not the owners, because I was not the one that deployed the contract. So to use the owner, we are gonna be connecting to the hard hat network instead. And this is the way that I'm connecting. If I'm configuring here, I need to configure the network of hard hat to connect to the blockchain. And in this case, I need to use, because we are using a local a browser environment, this is not running in the actual local host port. So to get the actual URL that this chain is running, we need to do this command, git URL 8545, and this is the actual browser URL that is this process is running. In your local blockchain, usually it will be localhost in the 8545, but this is a small caveat for using a browser environment. and this is HTTP. We are getting this one. This is the default chain ID for the hard hat network. So now we are connecting to the hard hat network. And the other thing that you might need to do is also importing the default hard hat seed phrase that we used previously, test, yank, and use it here to access the keys of the default hard hat. So now we check that we get the right accounts. And if we go here and connect to MetaMask, we are gonna see all the address that we have from, and we are gonna be able to see that we have the same owner. And now we are connecting to this. So now if we try to change to the owner to the previous, let's log out, copy this one, connect to MetaMask again, and change the owner to the burner wallet. Oh yeah, sorry, I didn't copy it right. If we copy this and now change the owner to this one, we are gonna need to submit a transaction with MetaMask in this case. Nonce too high. Maybe we need to reset. This is something that happens sometimes with MetaMask. We need to reset the accounts to get the right nonce. Now, if we send the transaction, probably we are getting we get the right, and we get the transaction, and now the owner changed. So now if we try to change again for us, we are gonna see the same error that we previously see, but it is playing in MetaMask. But if now we update this one and try to change once again to the other one using now the burner provider with the burner account, we are gonna be able to change this as we just see, and the owner is updated. And now to showcase the other example, we get this decrement. So if we decrement with one, we are getting the transaction correctly, and the value is updated. So we send once again, and we get the value 8. But instead, if we put to decrement 2 times, we're gonna see an error with no reentrancy, because the second time that it's trying to decrement is gonna give us an error, and the whole transaction is gonna be reverted and not executed. So yeah, this was the few examples that I wanted to show with this browser environment, and there are several more that are in the Solidity by examples that I'm gonna link to you. And I will be also encourage you to read through the whole Scaffold-eth documentation here, README, and I'm gonna put a few tasks related to this that I'm gonna share as well with the lecture. And finally, the only thing that I want to show before we finalize this lecture is that I did other demo like this one, but using TypeScript and typechain. And if anyone is interested in using that instead, you can find it in here, Scaffold-eth demo TS. It had everything is the same than before, but instead we have a few values here in hard hat that I'm using TypeScript instead. But we are gonna be seeing in next lecture much more detail about this. And yeah, talk to you soon.